Game Theory Class 12 Video 3. In this video we're going to introduce the concept of a mixed Nash equilibrium. So before we begin doing this, I'm going to redefine what I've been calling a Nash equilibrium this whole time. So from now on we're going to call the old style Nash equilibriums pure Nash equilibriums. We call the old style Nash equilibrium pure Nash equilibrium. And this is consistent. Pure Nash equilibrium involve pure strategies, and as we're going to see in a moment, mixed Nash equilibrium are going to involve mixed strategies. So let's move on to the definition. Here's the definition. So a mixed Nash equilibrium is simply just a pair of indifference strategies. That is all it is. A mixed Nash equilibrium is a pair of indifference strategies, one for each player. And the way you should think about mixed Nash equilibrium is it's a point where you force your opponent to, both players force their opponent to have no good option. No matter what their opponent does, it doesn't matter. Their expected payoff is the same because it's an indifference strategy. By definition of an indifference strategy, it makes your opponent indifferent to their choice of strategies. So a pair of indifferent strategies means that both players are indifferent to what they play. And this is the definition of a mixed Nash equilibrium. Again, I'm not saying mixed Nash equilibrium are necessarily the best result, but they are just a place where you sort of get stuck. Okay, so I'll note this down. Mixed Nash equilibrium are not always the best. Outcome. In the same sense that pure Nash equilibrium are not always the best outcome. Okay? And similarly to pure Nash equilibrium, there doesn't always exist a mixed Nash equilibrium. So mixed Nash equilibrium don't always exist. Like pure Nash equilibrium don't always exist. But we're going to talk more about that in future videos. For now, let's just do an example. So here's an example of a game that we've actually looked at before. Okay, it's a 2x2 game. Player 1 has the pure strategies A and B. Player 2 has the pure strategies X and Y. And the question is just calculate the mixed Nash equilibrium. Okay, well, we've actually examined this game before. In a previous video, we examined this exact game and we calculated the indifference strategies. And if you recall, the indifference strategy for player 1 is given by P equals 4/5. Or more concisely, I could write this as 4/5, 1/5. So that corresponds to 4/5, 1/5, like that. That's the indifference strategy for player 1. And the indifference strategy for player 2 is given by Q equals 2/7, or more concisely 2/7, 5/7. And this corresponds to this right here. Okay, so the mixed Nash equilibrium is, and you write it like this, big parenthesis, and then the indifference strategy for player 1, comma, and then the indifference strategy for player 2. This is the pure Nash equilibrium. Okay, I'm sorry, this is the mixed Nash equilibrium, and the way it's encoded is P 1 minus P Q 1 minus Q. That's what these numbers correspond to. Okay, so this example was very quick because we'd already worked out the indifference strategies in a previous video. In general, you'll have to work out the indifference strategies for yourself, which is time consuming. We're going to do more practice of this and examine mixed Nash equilibrium more in future videos. But that's the end of this example, and it's the end of this video.